Thank you very much. Thank you for inviting me. It's my first time in Jersey, and I very much hope it won't be my last time. And what a difficult act to follow from a fantastic talk from Andy. The Lego connection, I think, is fantastic. I must admit, we've had the idea in the past of perhaps trying to create a smart city, recreate a smart city in Lego. We haven't yet had the bottle to try it, but now I'm inspired to go and tell John that Andy's already started IoTing Lego, so we're behind. I'm just going to talk, so I'm going to briefly introduce Living PlanIT, and then I'm going to talk about the IoT and smart city space, which is a space that Living PlanIT operates in, and how that connects back to digital twins. First, just to extend the introduction to myself, so I've got a slightly unusual background. I was in the army for 9 years. I left and went into politics and was actually a member of parliament for 5 years. Unusually, I chose to leave rather than wait until I was dragged out by my fingernails. And while I was in Parliament, I was initially very interested in energy and climate change matters. I was on the Energy and Climate Change Select Committee. I got more interested in clean tech and then smart tech, ended up founding and chairing the all-party Smart Cities group before deciding to leave. And I now head up corporate development at Living PlanIT, but I also chair Smarter UK, which is part of Tech UK, and it's the Smart City, Smart Infrastructure initiative within Tech UK. So I would urge people to potentially have a look at Smarter UK and see whether there's anything there that is of interest to your organization. So Living PlanIT, as Joe said, we've been around for quite a long time. We're not a startup, founded in 2006. However, we're still quite startup-y in the way we do things. We're still quite small, we're still very nimble, and we're an unusual company. We've deliberately taken a long time to develop and harden what we consider to be an industrial-grade IoT and smart city platform. Anybody who tells you that you're going to run your mission-critical infrastructure from a Raspberry Pi and the cloud, we suspect doesn't really understand the challenge that they're facing. As a company, we're involved in the real-time collection, and we use the term real-time very decidedly, the real-time ingestion of data from multiple messy sources, being able to understand and interpret that data and use it to make interventions, including autonomous control directly from software, as well as informing manual interventions. And we have three principal areas of technology. The urban operating system, which is our platform that we've spent many years developing in-house and through some key acquisitions. We've recently moved into the realm of biological and self-learning sensors, initially focusing water quality and later air quality, using neural networks sitting behind relatively simple sensor heads to create a much more fine-grained view of the world at a much, much lower price point than existing industrial sensors. And then we have a very strong analytics and artificial intelligence capability that is not fully mature yet. This is not yet in the marketplace, but our chief data scientist actually won the Wiley Prize in maths for the work he did on multi-criteria decision-making, and we're taking what he did and we're effectively productizing and generalizing it. Now, we've heard a lot already about digital twins, and digital twins, I think, they're increasingly starting to take over as one of the new buzzwords in a sense. But absolutely rightly so. Some people might be aware that the National Infrastructure Commission in the UK has recently created a national framework for looking at how digital disruption is affecting the infrastructure sector. And one of their recommendations is to create national standards for digital twins. I'm actually on the roadmap working group for what that might look like. So the concept of the digital twin is gaining ground. Even government has started to notice that there's things called digital twins and are trying to see whether there's anything they can do to help. I'm on the working group making sure that they don't get in the way, because often I think when it comes to these things, the best thing government can do is step back. But if we can come up with a framework of standards that enables what individuals are doing at building levels, what people are doing at pieces of a level of equipment, all the way up to digital twins of cities and islands, if we can create ways to make sure that these things are as interoperable and can work together as possible, chances are that will be a good thing. Now, digital twins are not new. So at Living PlanIT, we have a very strong relationship with Formula One and motorsports. So our urban operating system, the real-time control layer, is actually built on the same technology that is used in Formula One, NASCAR, and IndyCar for understanding what's going on and controlling and optimizing what's going on in the car, in the engine, and in the business processes around it. People may not be aware that there are hundreds of sensors on a Formula One car that is traveling at 200 miles an hour around the track. And a huge amount of data from that car is being transmitted to the side of the track, where they run dozens of concurrent real-time simulations of the race. And they're doing that for two reasons. Firstly, they're using it to understand what is going on in the car, what is going on in the opponent's cars, what is going on the track, the weather, the tires, and they're using it to inform the driver's behavior. They're using it to optimize the performance of the engine and the physical systems on the car in order to improve performance in real time in the race right now, but they're also streaming that data back to their race headquarters, where they are redesigning the car a little bit for next week and a lot for next season, based on the real-time performance as it's measured today and compared with how it was measured last week and the week before and the week before. The current platform that's running, there's a standard platform for Formula One, has been in continuous operation since 1997, and they've been doing variations of this since the early 90s. They don't call it a digital twin, but that's basically what it is. And in fact, one of the reasons why Living PlanIT have a very close relationship with Formula One and actually acquired the platform that manages this and have incorporated it into the urban operating system and brought this capability into the urban environment is because we recognize that this extremely capable technology that's been running in Formula One has much, much wider applications than motorsports. And being able to take this ability to ingest data, measure, understand, optimize, and then put control back into the environment in real time and inform the design process for the next time you're building one of these things is extremely valuable for a wide variety of pieces of equipment or buildings and the like. But in order to have an effective digital twin, you need to have the data. And in some ways, there are, as Andy said, there are multiple definitions of digital twin, but there are, broadly speaking, I would say, two ways of looking at this. For some people, a digital twin is relatively static. A BIM model is a digital twin of a building. But a BIM model on its own is a static, design-based model of what the building should and could look like. We're more interested in the real-time dynamic digital twin that actually understands in real time what is going on in that building, that piece of equipment, or that city, and is able to integrate data from multiple sources to gain insights, but also to compare in real time that real-time data back to the model of what the data building or equipment should look like to either optimize performance or to improve the model, or really for a bit of both. Now, once you start to move beyond a piece of equipment or a car and start to get into the concept of a smart city, of a smart island, and a digital twin of multiple systems. I mean, a city or an island is a system of systems. You have energy, transport, healthcare, waste and water, electricity networks, communication networks. Each one of those is itself a system of systems. If you just consider the electricity network, and you consider you have generation, transmission, consumption, and everything that goes with it. So the ability to access real-time, meaningful data from multiple complex sources in order to inform a useful digital twin is challenging. And that's really where, in the context of today's discussion, I think IoT, the Internet of Things, underpinning a smart city approach is so important. Now, I try not to make too many assumptions when I'm speaking. I'm assuming everybody in the room does know what we mean when we talk about the Internet of Things and IoT. But the reason why there's been so much hype around IoT recently is pretty obvious when you look at the numbers involved. So venture capital, private equity, anybody who's got some money to spend has poured a huge amount of money into IoT in recent years because it's seen as an extremely hot topic. However, arguably, it's also been a little disappointing in places. I think there are some very, very clear and valuable use cases demonstrated by IoT, particularly in the industrial space. And as I've already mentioned, there are things, I haven't mentioned, but machine to machine and sort of digital twins type constructs in the industrial space are actually not new. But bringing them out into the wider world, into the world of buildings and cities and city systems, I would say the adoption of IoT has perhaps been slower than some people have hoped for. And in a little bit later on, I'm going to talk about some of the barriers to adopting IoT at scale and perhaps why that is. But the reason why this is absolutely real, and this is not going away, and this is absolutely key to developing some of the outcomes that we want to develop, is because of this growing and ever faster pace of technology disruption that is fueling this. A few little statistics for you to give you a feel for this. If you look at different technologies and how long it took different technologies to reach 100 million users since they were created, it's fascinating. The telephone took 75 years to reach 100 million users. The mobile phone took 16 years. Candy Crush took 3 years and 4 months. Pokemon Go took just 23 days to reach 100 million users from when it was launched. And this is because the way that all of those other digital systems out there, the internet, etc., have just opened up this marketplace, have made it easier to create things in software, to rapidly disseminate them, means that the pace of change is fast and continuing to get faster. And here's an anecdote that I actually borrowed from a Silicon Valley venture capitalist who said, my grandfather probably knew how many electric motors he owned. There was one in the drill, one in the car, possibly one in the fridge. My father had no idea how many electric motors he owned. How many electric motors are there in a modern car? I have no idea. But he certainly knew how many microchips he owned. I have no idea how many microchips I own, but I know exactly how many connected devices I own. But my children will have no idea how many connected devices they own. And in fact, they won't even make that distinction between a device that's connected and a device that isn't. Because to be frank, almost everything they own will in some way or other be connected. And I think looking around the room, everyone here is about the right age for me to say this. I'm sure we all remember a time when going on the internet was a thing you did. You had a special place in your house where you unplugged the phone and plugged your computer in. And after half an hour of doing whatever you were doing, you plugged the phone back in, you logged off, and you went about your business, no longer on the internet. Well, I mean, how alien does that sound already? The concepts of being online and offline are already completely blurred, and our children won't even know what these terms mean. That's the context behind which the growth of connected devices and IoT is happening already subtly, and it's just a question of harnessing this in aid of the smart city approach, of the digital twin approach. Now, I said I'm not going to teach you how to suck eggs, but the concept of IoT is really, really simple, and sometimes I think people overcomplicate it. What's quite interesting is Andy mentioned his, start with the answer, work back through processing to the data you need. Well, that's this. If you consider this is the answer, this is the processing, and this is the data. It is just about gathering data. And in our world, where we think in terms of smart cities, so Living PlanIT and the sort of the platform, it's gathering data from multiple sources and untethering it from single use. So that you gather data for a particular reason, but you make it open, you enable it to be used for other things. Keeping it safe, relevant, and accessible, obvious. You need to express the past and the present so you understand what's going on in real time in the context of the past. And integrating and normalizing data from multiple sources. But that's tricky. And in fact, in some ways, this is almost the hardest bit. And there are many people who thought that this is the easy bit and have come a cropper. And there are plenty of IoT advocates and companies who will tell you all about the exciting analytics they can do in the cloud, show you some great dashboards. And they wave their hands over the gathering of the data bit. And they sort of say, give us your data and look what we can do. And actually, sometimes this is the hard bit. Because data is noisy, it's imperfect. Most systems and equipment out there today were never designed to share data beyond their own little bit of firmware or what they do. And actually breaking into and accessing the huge amounts of data that already exist and opening them up and making them available is in itself a huge challenge. Data comes in at different times, it comes in from different places, and being able to manage that is quite tricky. Then the insight bit, of course, is what do you do with it when you've got it? And how quickly do you do it? I'm going to keep alluding to Andy because he had such a good speech. As Andy said, there's no point in gathering data and saying, God, this would have been really useful to have known this now. Last week, X happened. So it's about understanding what's happening in real time and over time, enabling yourself to find meaning, to apply real-time analytics. Possibly that's AI, possibly that's machine learning, possibly it's a human pair of eyeballs. But being able to understand in context, the context of time, space, and activity, to start to enable correlations, to enable that analytics and AI environment, but to support effective decision-making, to do this. Because if you're not making an intervention, by which I mean doing something differently to what you would have done if you didn't have the data, what's the point of all that lot? Some of that might be immediate interventions, and in our world, Living PlanIT, we're great advocates of we refer to our platform as the data and control platform, because the ability to do autonomous, real-time control and interventions based on these processes in some instances is critical. In other areas, you may be informing longer-term change. You may be creating insights that enable city planners to better plan what the next road route or rail network might look like. Some of these will be autonomous, some of them will be manual. But ultimately, this is about improving outcomes. And we all talk about the triple bottom line. Improving economic outcomes by cutting costs or creating new business models. Improving the environmental sustainability of what we do. But ultimately, it's about the experience of the passenger, the customer, the patient, the guest, the citizen, whatever the particular model is, because it's about this. It's about improving quality of life. If we're not doing that, again, I question what we're doing any of this for. So I'm not going to dwell too much about the urban operating system, but in effect, Living PlanIT has created a very, very flexible very scalable, real-time data analytics and control platform. It's built in part upon the same code that manages Formula One. We also, along the way, have acquired a number of companies in the intelligent building control space. We do a lot in buildings, simply because buildings are, by definition, the building blocks of cities. But effectively, it's a platform that could run a single apartment or a single fan core unit or air handling unit or an entire city. And it has a very elegant multi-nodal architecture that enables it to scale very, very smoothly. And we believe very strongly in edge processing. We've split the platform into two layers, the control layer and the core layer. The control layer is designed to be embedded, designed to be distributed, and it's the real-time analytics and control environment for managing mission-critical equipment. The core or supervisory layer is the higher-level aggregation layer that could be on-premise, could be in the cloud, or could be a hybrid, where you connect up all those multiple real-time control nodes, potentially suck in additional third-party data sets, and do perhaps the bigger iron, longer-term historical sort of pattern analysis. But the key point here is that it's an open standard platform. We are hardware agnostic, and to a large degree, we're agnostic to the application layer. This is about delivering integrated, normalized, real-time, analytics-ready data through open standard APIs and open standard protocols to enable other people to create a vibrant third-party ecosystem of applications. And this concept of city as a platform, again, I'm sure it's not new to you all, but if you think about the way an iPhone works, it has a small number of sensors, it has some computing power, it has the ability to visualize things on the screen, it has an always-on data connection. And Apple have not tried to create every possible way of using those combinations of things to sell to you. They opened up the App Store, and I think the current statistics are something like $24 billion a year worth of applications are sold. Millions of different ways of leveraging, I know it's more than 6 now with the more latest iPhones, the data that comes from those small numbers of sensors. But the key point as well is that the application layer are sharing the infrastructure. Each app doesn't come with its own new sensor, or its own screen, or its own microchip. They share a common digital platform. And just imagine what would happen in a city that's genuinely operating in the same way. Billions of sensors and data points, huge amounts of data, actuators, so much going on. And if you had a genuinely shared digital infrastructure, and you're not trying to recreate the wheel with every single use case, the opportunities are huge. And we at Living PlanIT think about infrastructure as having two layers. You have the physical infrastructure, buildings and equipment and machinery and building systems. You then have a layer of human activity that sits on top of that. Now, that could be a hospital or a hotel, it could be residential, it could be retail. There's all sorts of things people do in buildings and people do in infrastructure. And the two cannot be separated, because the single biggest factor that affects the efficiency of a piece of infrastructure are the people inside it and how they use it. But similarly, how you design your physical infrastructure actually affects how people go about their day and go about their business. Winston Churchill once said, "We shape our buildings, and thereafter our buildings shape us." And this is absolutely true. And so we're great advocates of being able to connect to both. Now, I haven't talked a lot in this presentation about specific use cases Living PlanIT do, so I'll mention a couple here. We did a fascinating project, partnered with a number of people, IBM, et cetera, at London City Airport, partly funded by the Technology Strategy Board, where we demonstrated a smart connected airport with multiple use cases within an airport: smart retail, security, passenger journey planning, queue management, physical asset tracking, all on a common platform, the Urban Operating System. Other than connecting with cameras and sensors, we weren't physically controlling any of the equipment. It was purely a human platform, understanding the movement and activities of passengers, helping them improve their flow through the airport, and being able to intervene at times and improve their experience, while at the same time improving the outputs from retail, from security, queuing, et cetera. We're doing something very similar in retail. If anybody's been to Birmingham and been to the Mailbox Shopping Centre, a beautiful high-end shopping centre in Birmingham, the retail application, the smart retail platform, is running on our software. Similarly, when it comes to physical buildings and infrastructure, connecting up building management systems, we're doing this in hospitals in the Middle East, we're running in a number of commercial buildings in London, and being able to do both is fascinating. And in fact, in some ways, we're still looking for the perfect example use case, because people tend to want us to do this or this, which is fine, but we're waiting for somebody who's actually going to really let us go to town on a complex building where we're doing both. And hopefully we have that project coming up in Portugal. Who would not want to be involved in a project called The World of Wine, where Fladgate, who own all of the beautiful old port warehouses around Porto and Gaia, are creating a €100 million sort of mixed-use destination with museums and hotels and restaurants and shops in the beautiful white port warehouses. And hopefully, our platform is going to not only physically run the infrastructure, but also provide the human platform, the retail, and the sort of experience platform. And that will be a really, really fascinating example and a fascinating use case. So to give a really simple, illustrative example of what I mean when I talk about a shared common digital infrastructure. So this is a PIR sensor. I'm sure you've all been into a meeting room where the light comes on when you walk in the room. Brilliant. I would bet everyone in this room, apart from Andy, who's probably doing it differently, $1,000 that when you walk into that room, that data is only talking to the light. Really useful data. Someone's in this room. Secondly, I bet you another $1,000 is not being kept to enable you to model how the room is used. It's a typical example of a point solution and a wasted use of a sensor. And in fact, it's brilliant when I'm sitting in a meeting room where they have one of those and a CCTV camera in the corner, because then I can say, look, you've got two sensors doing the same thing, looking to see who is in this room. One's talking to the security system, the other one's talking to the light, and neither of them are telling the heating or the cooling system that there's anybody in here. So in our world, you still have a PIR sensor or something similar. You have the minimum required set of sensors to understand what's happening in the room. But instead of being wired directly to the light, it goes into an open platform. A platform, the light knows no different, because the light subscribes to that data in real time and still turns on. But at the same time now, the HVAC can subscribe to that data. The security system can subscribe to that data and say, why is there someone in that room at 4 in the morning? My pattern detection software tells me this is an anomaly and I should send an alert to somebody. So it's a share, and half the time, all these various sensors you have in a building these days, not only are they not sharing the data, they're not even sharing the bloody cabling or the compute platform. You'll have literally a different computer running the lights to the one that's running your access control, to the one that's running your security, to the one that's running your HVAC systems. I apologize for my not quite so nifty slides as the IBM slides. I pulled this together quite quickly because it's an example use case I often talk about, and I wanted to try to capture it, to give a similar example in a sort of a city and air quality environment. We could all imagine today, in fact, this probably exists in cities up and down the country. There is a school, and children walk to school, and there's a half-hour window in the morning and a half-hour window in the afternoon when there's a lot of children walking up this road. The only people who really have any access to any of that data is the school and the parents. There's a traffic light that's probably running on a timer. In this case, somebody's put an air quality sensor in. That data is streaming off to the university where it goes to a professor's laptop and lives in an Excel spreadsheet, and nobody else ever sees the data from this. And then there's some cameras watching congestion and traffic movements that stream off sideways to a highway agency area where they sit in another separate siloed system and two people look at them occasionally. Now, just imagine if we have exactly the same physical infrastructure but with a shared data environment. And you can start to potentially identify correlations between poor air quality and congestion. And it's entirely feasible that that could be linked to the traffic lights, whereby when the traffic lights are red for a long period of time, cars are sitting idling and the poor air quality gets poorer. And we know when the critical windows for air quality are because when the children are walking to school. And how it would be relatively simple. Now, it's not simple to get that connection together, but once you have, it's relatively simple to think about how you can then make some interventions to say, well, maybe between 8 and 8:30 in the morning and 4 and 4:30 in the afternoon, air quality becomes more important in this location than traffic movement. And so possibly rephasing the traffic lights and maybe some other traffic lights around the system could reduce the amount of congestion here and bring down air pollution during that critical half-hour window when these school children are walking to school. Now, it might be that doing that creates more congestion elsewhere in the city because you've rephased the traffic light. But that's a judgment call that you might wish to make. But it's a judgment call you can't make. It's not even an option for you if you don't have this shared data environment that enables you to do that. And so in city terms, this city as a platform concept, again, it's still actually a pretty simple concept, even if it's quite hard to do in reality. You have the physical real world of cars and buildings and sensors and actuators and cameras and lights and whatnot. You have a platform. Other platforms are available. In this case, I'm using the Urban Operating System as my example. But you have a real-time data analytics and control platform that enables you to ingest this data, understand it, normalize it in real time. And in this case, we often talk about the concept of having an urban app store, Because this isn't about creating a closed end-to-end system, the sort of thing that the government of Dubai or Singapore might impose on their city. This is about an open standards platform, one that then enables, potentially through something like an urban app store, a vibrant ecosystem of different applications to make use of that data, more akin to the Apple App Store than to anything else. Now, this doesn't have to be an entire city. You could replace this slide with a building. And these could be the building management systems, the sensors, et cetera, within the building, and you could do the same thing. However, most smart city projects around the world today look more like this. I like to be controversial. I like to hold up Barcelona as an example of how not to do a smart city, which is a little mean, I know, because they pioneered the way. But the fact is, most cities will have a number of smart city projects that they like to showcase. So they might have a smart parking solution where they have some sensors streaming data up to a database in the cloud, and they do some chopping around, and then they send it up to an application that helps people park. Meanwhile, a different part of the city are monitoring traffic congestion with cameras and streaming up to a completely separate data infrastructure, possibly in a different cloud with a different database and a different canonical data model, streaming up to their app. And the two of them don't talk to each other. And each one on its own looks quite cool, looks quite funky. But actually, it's another silo. It's an IoT-enabled silo. And you can see where I'm going with this. Having a shared data infrastructure saves money and improves outcomes. Now, this doesn't necessarily mean that these guys are sharing anything. Their business model and their business model might look and feel exactly the same. The only difference is they're not reinventing the wheel in the middle. And that might not seem important when there are 2 of these. What about when there are 10? What about when there are 1,000 projects across a city? Does every project really going to have its own dedicated, separate, standalone, and incompatible digital infrastructure? You'll quickly fall apart, and you quickly will not be seeing the benefits that you want to see from your smart city. This way, not only can you cut CapEx and cut costs, but the ability to start sharing data comes in, because it's obvious that the guy managing congestion, in this case, might find it really useful to understand the parking patterns and how that impacts on congestion as people are driving around looking for parking spaces. So he might want to do a deal with this guy and access some of that data. And similarly, the car parking guy might find it very useful to know where the congestion is so he can route people to the car park in other ways. Now, this could be open shared data where people are sharing it through the goodness of their heart, or money might change hands in order for this data to share. And I'm all for that. This whole point about open data versus not open data. Data does have a value. And to my mind, we'll really know we've got fully open smart cities when we have a functioning data economy alongside it that enables people to potentially swap data or monetize data as well as share, when necessary, open data. So why aren't all our cities doing this already? Why aren't all real estate developers putting this stuff in their buildings already? Well, the pioneers are. Jersey, the pioneers will be there, I hope, as a really early example. But of course, there are lots of challenges and problems. I'm sure you know a lot of them. But I mentioned earlier, accessing and converging data in the first place is tricky. It's tricky physically. It's sometimes tricky in policy terms. Budgetary silos and departmental silos don't always make it easy, even within an individual organization, let alone doing it across multiple organizations. There's a massive cultural and organizational thing here. Change management is hard in any organization, let alone change management plus new technology. Security and privacy concerns are obvious ones. The perceived extra cost is an interesting one, because in some cases, there is an extra cost. But it partly depends on how you go about doing it. We're great believers that actually there's a lot of money being spent already on infrastructure and service delivery and facilities management. And spending that better is often the key. And a lot of people do try this big bang top-down approach. We have to do it all. We have to do it all at once, and we have to do it all in one way. And that sort of fear of adopting the wrong solution, we also find quite often, this idea, nobody wants to buy Betamax and find the rest of the world has gone VHS. But I think one of the main reasons, and I was asked to include a discussion of ROI in my talk, is this one. I'm sure any tech vendor in the room has sat and spoken to cities or customers with a great idea, lots of nodding, and then the last minute, the guy says, can you show me where people have done this before, preferably several of them, preferably with several years' worth of ROI, so that I really know that what I'm doing is going to work. And of course, the answer is, no, this is cutting-edge stuff, but you can be the pioneer. And then you see the fear in their eyes, and they don't do it. So I think getting through this, I'm a great believer that we're going to hit a tipping point, and I hope Jersey will be part of that, where we're going to have more and more demonstrable use cases which are going to help, significantly help, move the market forward. I'm conscious time's ticking. I'm just going to talk very briefly about how we've approached this as Living Planet in the building space. This is very specifically real estate, the smart buildings. So what we do in buildings, probably far too complex a slide for me to put up. So what we're very, very keen to do here is not just connect up those individual systems, the HVAC, the lighting, the heating, and security, but strip them away altogether. No standalone proprietary building control systems. Just software, the urban operating system, stuff, physical equipment, and all of those individual building controllers become virtual controllers. They become control applications running in a common software environment with a common data environment and a common sensor environment. Now, this is actually pretty radical in the building management world. I'm not going to dwell on that because this isn't a conversation about building management systems, but we had a really interesting epiphany moment when we were talking to one of the very, very large London-based real estate developers at a big 40-acre site, 2 million square feet of commercial, 1 million square feet of retail. We spent a whole day with them talking about smart cities and smart districts and campuses and buildings, and lots of nodding. And then at the end, the director responsible said, "This is great, Dan. Of course, we can't do it." And I said, "That's disappointing. Why?" He said, "I will be honest with you. I don't know how to break our process in order to do things different enough to deliver this, even though I want it. So we're a sausage machine. We operate on relatively low margins, we're good at what we do, and we do the same thing every time. Get the land, get the planning permission, get the architects, blah, blah, blah. At the end of it, we got a bunch of buildings." So we went away and we thought hard about this. We ended up going back and repitching them in a totally different way. The same concept in a totally different way. We said, forget smart cities, forget smart buildings. You've got a budget line in your project for building management systems already. So we will fit within your existing budget line. Don't worry about all of your procurement processes. We're only asking you to look at one of your procurement processes, and that is BMS. And you might need to look slightly differently at that, but not too differently, because effectively think of this as buying a different BMS system. Once we're in and running your building with a lower CapEx, saving you 30%, possibly 40% OpEx on energy savings, so you've got a business case for that. You've now got a capable, flexible IoT platform running in your building that can be extended. And the marginal cost of doing other things now has just collapsed. And the new business cases for the smart building and then later the smart city stuff are starting to write themselves because you've already got the physical infrastructure. And that approach, that kind of bottom-up and value-out approach, we find is much more useful than the big top-down approach. So I sort of came up with my quick list of suggestions based on that this is really the way we now try to think about selling IoT. Where possible, fit into an existing budget line. If you're expecting someone to find a new budget for what you do, that's possibly tricky. Where possible, fit into their existing procurement and delivery processes. And that's probably almost more critical, because these guys, especially in real estate and infrastructure and local authority, are not necessarily that good at changing the way they deliver things, and that's because none of us are. Change management is hard. Too many people in the smart building and smart city world lead with the intangible, lovely, fluffy, nice-to-haves. I mean, I've literally seen people talking about smart buildings. The elevators will note that you're walking up the corridor and pre-call themselves to your floor. Lovely. Where's the business case and the ROI for that? Well, if you only need a couple of extra sensors to do that because the platform itself was paid for by energy, great, you can do it. So you don't lead with the intangibles. You find the anchor use case, the clear business need that will be addressed. And a key one here is avoiding new silos. Because most people do half of this. They will narrow in on a narrow business case. And in buildings, it's usually energy, because it's easy to work out the ROI on saving 30% of your energy. But then they'll create something that's all it can do. And that if you then want to monitor water quality or put cameras in the car park to do smart parking, they become new silos again, back to that earlier slide I put. So do it in a way where the anchor use case is funding a shared digital infrastructure. My light's flashing at me, but I'm going to take a couple more minutes as I go. And so you reduce the marginal cost of the wider use cases. And then the key one, perhaps, of course, is the bottom one. You have to be making a positive difference, a positive outcome. Otherwise, what's the point? So summary. Digital twins are absolutely critical, I think, moving forward to delivering infrastructure and services in new ways. And we have to do it. I've got a much longer presentation where I talk about the Barnett graph of doom that some of you will be familiar with. If you don't know it, Google Barnett graph of doom. Basically, we can't keep delivering infrastructure and city services the way we always have. We have to do something differently moving forward. And the way to do that is through the digital twin. It's through using data. And in our world, we believe that IoT is a key enabler for that. And it's about this top thing. It's about creating a shared data environment, a shared sensor environment, and a shared digital environment so you're not doing things in silos. Converging the data, historical and real-time, enabling those analytics. Open standards, so that you can have this vibrant application layer, this third-party ecosystem. And ultimately, it's about these bottom things here, improving efficiency, improving outcomes, and improving the user experience. Oops. So, I unfortunately can't stick around. I'm hoping there's time for a few questions if anybody has any. Unfortunately, I'm flying to the Middle East this evening, so I'm going to have to rush off at about 12:30. My details are there if anybody's interested in following up. And thank you very much. Hope that was helpful.